So greetings everyone. Good morning. Today we are from Group 1 from Grade 8A, and today we will be presenting our model demonstration of our Smart AC model. This group consists of 8 members, which are, hello, my name is Gabriela.
My name is Tristan.
My name is Andrew.
My name is Reina. My name is Denson.
Okay, let's start from our background of our model. To begin with, our air conditioner model is based on very basic materials, but then we transformed it into better and also efficient electricity, yes. So as you can see here, our model consists of electricity wiring and also learning about airflow, which helps us to educate other people about simple basic engineering stuff. And also, in this model, we can demonstrate how airflow and cooling effects work. And lastly, it is interesting because our presentation will consist of have something done, earth stream objectives, phrasal verbs, and also passive verbs, and so much more, which are vital because our presentation consists of step-by-step process explanation.
To create this model, we use several materials. First, cardboard. Second, electrical wiring. On-off switch, propeller, battery, cable, adapter, solder, register, ceiling fan, flexible pipe, air 1K, windlet, DC motor, charging socket, aluminum foil, nickel plastic, cotton paper, scissors, cutter, hot glue gun, double side tape, clear tape, rulers, and marker.
I will do it instead. Okay, so these are the step-by-step process. So we have switch 1, which, LED monitoring and safety circuit, which acts as the primary indicator and monitoring system and is connected to resistor, the tuned LED lights, and battery power source. And the resistor controls electrical current to prevent LED overload, which is bad. LED overload is bad. LED system functions as a power status indicator, like the green light there, and the fault detection indicator, in which, in case someone breaks it, it doesn't work. And dude, it's the wrong one. Okay. So I'm gonna explain this one. So electrical current flows from the battery through the resistor before getting into the LEDs. And it helps to stabilize the low voltage circuit inside the model and improves electrical safety and circuit efficiency, which will be important for later. 6.2.
As the internal air circulation system. This subsystem is connected directly to multiple batteries, DC motors, and miniature cooling fans. The batteries provide the independence, low voltage energy for electrical and calculation.
responding right now. Let's continue to switch 2, aka the internal air circulation system. And it is connected, switch 2 is connected directly to the dual battery supply, 3 DC motors, and 3 miniature cooling fans, which are red, yellow, and green. So batteries provide independent low voltage energy for internal ventilation. And also the DC motors convert the electrical energy into rotational mechanical energy. And the rotational motion activates as the fan blades. And these are the interesting facts about small fans. So it improves internal air circulation, which is very good, cooling distribution, which makes it more efficient, and ventilation efficiency, which is also efficient. And yeah, we have the multi-vent configuration, and it increases the airflow consistency throughout the chamber, and it helps reduce heat accumulation inside the system too, which is very, very good.
Okay, now we got the switch 3, which is the main power distribution system. This part. So it functions as a central electrical control system and connected to 2 cables, which is that 2 cables connected to a positive cables of a 12-volt fan, 5-volt fan, and also the positive cable of the plug over there. And also another cable which is consists of all negative cables, which is from the 12-volt fan, 5-volt fans, and also the negative cable of the plug. And it's organized the electrical flow throughout these separated systems so that they can turn on. Socket transfer external electrical power into the system and supplies it to the larger 12-volt fan, which is over there, and the small 5-volt fan, which is here. And this large fan generates high pressure airflow for stronger cooling systems. Small fan supports secondary airflow stabilization. Simultaneously, fan operation improves air pressure balance, cooling efficiency, and also continuous airflow circulation.
Okay, so the next step is integrated cooling operation. Airflow. So the first thing I want to explain to you guys the airflow process. Warm air is pulled into the chamber by the large fan. Air passes through the internal cooling section, and then internal fans redistribute cold air evenly. And the last one is continuous airflow to prevent thermal buildup. The second thing is electrical system coordination. Each switch controls a separate subsystem. Then combined operation creates a synchronized cooling mechanism. And the third point is independent switch configuration improves. So there's 3 parts, which is first one is circuit organization, the second one is power management, the third one is system troubleshooting. And the last thing I want to explain to you guys is the structural advantage. The first one is the cardboard structure provides lightweight insulation. And then the internal compartments improve airflow direction. The third one is multiple fan system increases ventilation performance. And the last thing is compact design allows portable operation. Next.
Okay, so we're gonna do the model demonstration time with me and Reynard.
Let's go.
So how this machine work? First, Reynard gonna lift the ventilator this side. So as you guys can see, this is the fan, and if I switch this on, this fan gonna turn on, and this fan's function as the air gonna suck in here, and the air gonna go down the tube and go here. And I'm gonna switch this on. What is this for? as if you guys can see, this is the green light. So if there is something wrong, I can immediately fix it from here. And I'm gonna turn on the first switch, which is the fans. And these fans inside here, as you can see, is moving. Wait, let me now, as you guys see, it's moving. It's gonna push the air from here to out. So it's gonna push this air out of this tiny space. As you So yeah, only like that.
So, what interesting about our project is the cooling system. The cooling system inside of the box, and this is the name is air conditioner, and it's even this project is simple and it's expensive, but this is a good project that I see. So, the cooling system inside the box is actually a primitive, and the cardboard that used is dirt cheap and not fragile. Then the fan used to blow the air is swift. The high speed DC and fan force the air to pass through the ice compartment. The air coming out from ventilating pipe is fuel stealing for short periods. The sound make the high speed DC fan inside the box is defining.
Okay, so first switch. So the conclusion is the first switch connect to a resistor, to LED, and the battery. So the first LED monitoring system is activated to switch 1. The electrical current is controlled carefully by the resistor. Second switch connected to 2 batteries and 3 DC motor. So the DC motor helps the electrical current to make the motion. Each DC motor is connected to a small fan. So the DC motor is connected to a small fan. And last, third switch, connected to a positive and negative cable lines. Electrical power is distributed systematically through switch 3. Both the larger ventilation fan and the smaller auxiliary fan is connected. Overall, this process was completed successfully through our teamwork and also our time management.
Next. Finally, the conclusion. That was the conclusion of the process. Now here is the conclusion of the overall model building process that we went through. So first of all, we have successfully made a model which is pretty simple, very basic, using very simple and also well-constructed materials such as electrical wiring, cardboard, carton paper, batteries, and so much more, which sound pretty simple and is pretty common in household things, but then with teamwork and also communication and also expanding our knowledge in certainly electricity, we've managed to create this model. Secondly, this model has demonstrated how airflow works, specifically regarding about science, about how temperature, cooling effects, and so much more. Third, we've showed how motors, switches, and wiring work together. They compile, which basically created this whole model. Fourthly, during this process of making the model AC, not all of us were compatible for doing the wiring and such, but we've coordinated and also we've learned how to expand our knowledge. Moreover, we learned how to help each other and also to complete each other with our own talents and also our own knowledge. And moreover, we learned how to use proper grammar when we're trying to explain a process or a project, such as using has something done, we've used passive verbs, we've used extreme adjectives, And also we've added sequence markers such as firstly, therefore, moreover, lastly, and so much more. And also we've improved teamwork, and lastly, the vigilante. We've learned that God created us very wonderfully made. Each of us has our own unique talents, and we've used that talent to complete each other. Some of us are good at electrical wiring, some of us are good at designing, but we've learned how to do teamwork and combine each other. Now, we've come to an end of our presentation. Anyone wants to ask about anything? Yes, you may go, Josh.
Oh, hello, I'm Josh, and I would like to ask a question. What was your biggest challenge when making this model, and how did you overcome it?
Who wants to answer?
Me. Okay, so our biggest problem making this AC, which is the third switch. Like the third switch is there is a lot of cables to be connected, and without Reynard and some of you guys, I cannot do it alone. So yeah, I need my teammates to help me in the third switch, which is successful now.
Thank you.
Thank you, Josh.
Thank you, Josh. Would anyone else want to ask
Dylan.
questions? Yes, Jill.
So,
Introduce.
my name is Jillian Rose, and here I want to ask if you guys can feel the air coming out of it, and if it's cold or if it's just the same air as in the temperature in the room.
Barely. It barely has like it just the vent just moves. It doesn't feel it. I
Okay,
feel
we
it
have
actually.
some problems. So first of all, the ventilator is actually pretty cold. If you can feel from the side beforehand,
Just the
try to try it.
ventilator.
But the problem is our our scale of our model is pretty big, and the motors we've used inside are small propellers, which aren't really compatible. Which is why when the air is coming out, it's not really that cool. But would you like to try and feel it?
I'll try it later.
Yeah.
It doesn't.
It's not the best, but for a DIY model, it's pretty cool for us.
Yeah, that's really cool. We just need bigger friends so we can have more cool air.
Sure. Okay. I would like to wrap our presentation. Thank you so much for all of you who's asking questions and also being attentive. Thank you so much.
Thank you.
Thank you.